Okay, this lesson is on reciprocal functions. All right, so how do I graph reciprocal functions? You may remember back in the day when we transformed a function, like a quadratic function, how it looked. It kind of looked like this, where we could move it side to side, left and right, or up and down. When we did this one, remember it was kind of opposite of what we thought. So if it said x plus 4, we went to the left 4 rather than to the right 4. And then this one was up and down, and that was just normal. And then we could also stretch a function by doing this, or compress it. If the number was bigger than 1, it was a stretch, and it stretched away from the x-axis. Or we could compress it, which would get closer to the x-axis, and that was if the number was between 0 and 1. And then it also got reflected across the x-axis if it were negative. So those were all things that we did with quadratic functions last year, and then we did a bunch of that earlier this year with other functions. So we practiced that quite a bit. All of those same things still apply to what we're going to talk about today with reciprocal functions, and then in our next lesson on rational functions. They're both a type of rational function, but they're a little bit different. We're going to start with this one first. So this is the reciprocal parent function. It's 1 over x. So what does it look like? Well, we'll do that first. It actually has two branches with a couple of asymptote lines. And if you remember, an asymptote line is a part where the graph will get really, really close to that, but never actually reach it. So in this particular case, we have an asymptote line when x equals 0, because we cannot have this equal 0, because I can't divide by 0, remember? So one of my asymptote lines then is when x equals 0, and that is y. So that's a vertical asymptote. We can't have x equals 0. So you can see here, that's this line right here, that red line. I made it dashed just so you kind of know what we're talking about. Also, we have a horizontal line. If I were to make this x really, really big, like infinity, my fraction then would be 1 over a very, very, very large number, which is really close to 0. But because there's a 1 on top, it would be really close to 0, but not quite 0. So I could never actually reach 0 for my output. So I also have a y equal 0 horizontal asymptote. Okay. So hopefully that kind of makes some sense, at least, as to why. If not, we'll talk more about it. That's okay. All right, now we're going to graph this. And you can do this by just putting in a couple of points. If I put a 1 here in for x, I get 1 over 1, which is 1. So one of the points would be the 0.11. Okay? If I put a 2 in for x, I would get 1 over 2. So when I put a 2, I'm at a half. If I put a half in there for x, I would get 2. So you can kind of see I have this. And basically what happens is, let me try to draw this a little bit better. We'll see how that goes. Is I get this curved sort of line on this branch that gets close but doesn't quite reach those asymptote lines. And then the same thing happens on the other branch. So, okay. And then I have another branch that just kind of goes. So this is not a continuous function. There is a break in it. So this is called, the type of graph, the name for this is called a hyperbola. So I'm going to write that in here. Okay, well, what is my domain? What can x be? Well, basically, x can be anything except I can't put a 0 in the denominator down here. So really, x cannot equal 0. Now, the way we're going to write this is probably new notation for everybody. Okay, hopefully my pen works. There we go. I'm going to do a little squiggly bracket, and then we're going to put an x there because domain is x, and you're going to put this line here. That means such that. So far what I've written is x such that x cannot be equal to 0. And this is what you're going to see in a lot of upper level math is how they'll be written. So you're going to say the domain is anything in x such that x cannot be 0. Anything else is fine. Okay. Well, how about the range? Well, because you'll notice that this and this, right, match. The vertical asymptote is at 0, so I'm never actually going to reach it. So I can't get there, so x can't be 0. Well, so then my range is, remember, range is y. So y such that, and we know also that if you look at the graph, that the y value can't ever reach 0 either. And I explained why. Again, if I put a 0 or an infinity in for x, it'd be 1 over infinity, which would be really, really close to a 0, but not quite. And again, those two things right here are tied. Okay. That is always the case. So again, this is called a hyperbola, and a hyperbola has multiple branches, okay? So we're going to look at these kinds of functions, and we can transform them the same way we transform other functions. So here's the standard form of a reciprocal function. You'll notice a lot of the similarities, and the things are really the same. So let's start with h. So this is still going to move the function right and left. And it's going to be opposite of what you might think. The k value, I guess we'll keep that in blue, still up and down. And that's going to be normal. And then the a value still does reflections across the x-axis. And then it's also going to stretch or compress. In the same way as before. If the number is bigger than 1, it's a stretch. If it's between 0 and 1, it's a compression. Okay, so cool. Also, I can't have the denominator be 0. So I'm going to have a vertical asymptote at x equals h. So for example, let's say down here, I had x plus 4. So then what can x not be? What would make that equal to 0? I would have a vertical asymptote then at x equals -4. Because that graph cannot have 0 down here. Okay? And then a horizontal asymptote at k. So whatever k was. So if you had, let's just say this is a 1 up here and then plus 7. I would have a horizontal line that I would never reach at y equals 7. Okay, so those are the important things to know. So now we're just going to practice a little bit. Okay, it says write an equation to represent the new function and identify the asymptotes. Here it says the reciprocal parent function, which I have written here. Okay, I mean the parent function is 1 over x, right? But we're going to modify that using the standard form of that. It's translated 4 units to the right and 3 units down. Okay, so let's see if we can write our equation. I know then reflected across the x-axis. It doesn't say anything about a compression. let's call this one g of x, or a stretch. There's no compression or stretch, so that I can assume this is a 1 still. Otherwise, that would have changed. It does say it was reflected across the x-axis, so that means this has to be negative. Okay? So I've handled that part. Now, 4 units to the right. Okay, well, that's the h down here. Now, to the right, normally is positive, but remember, this is where it's opposite, so I'm going to write x minus 4. And then 3 units down. So that is normal. My k would just be minus 3. There. You've just written the function. That's it. Okay? Now my vertical asymptotes and my horizontal asymptotes just match the stuff that I have here. So I'm going to, for the vertical asymptote, I want to say, when would this be equal to 0? That's when x is equal to 4. Okay? And then what's my horizontal asymptote? When y equals negative 3. And that's it. So that's just getting used to how would you write a function, what are the vertical and horizontal asymptotes. Let's try again. Okay, same thing. I'm going to call this one c of x. Okay. All right, let's see. Reciprocal function is translated 7 units up, so I'm going to say plus 7. That's my k. All right. 1 unit to the left, so that's my h. So to the left, that would be plus 1. Because opposite. Normally, to the left is negative. I want to do the opposite, so it's positive. And then vertically stretched by a factor of 2. So 2. Now, they don't say anything about reflected across the x-axis, so I don't have any negative there with the 2. Okay, my vertical asymptote would be when that denominator is equal to 0, so that would be negative 1. My horizontal asymptote would be y equals 7. That's just going to be that always, so that's a little easier. Okay. All right, so this one, they tell you, all right, what is my vertical asymptote? And they also tell us our horizontal asymptote, but they don't tell us the other stuff. So we still need to write the function. So I know that my vertical asymptote, let's write that. There we go. Is equal to x equals negative 2. My horizontal asymptote, y equals, well, that's negative. I don't know what happened to the negative. There we go. All right, 5. So I don't have any other information other than those 2 things. So there could be a stretch. There could be a compression. That is not really in there. So I just need to assume as best I can what that might be. So let's call this one h of x. Okay, now if my denominator has a vertical asymptote of negative 2, that means this would have to be x plus 2. And then my horizontal asymptote is 5, so that should be then plus 5. So there's a function that has that. Done. Okay, I hope that makes sense. Now what we're going to try is to do a little bit of the graphing. And this will be weird at first. We'll get better at it. It says graph the function, identify the domain, range, and asymptotes. I think it's oftentimes easier to do that first. So I like to just do the vertical and horizontal asymptotes first and then kind of go from there. So vertical asymptote would be just x equals 0, right? Because if I look at this down here, I can't have that be equal to 0. So I'm going to write that in here. Okay. My horizontal asymptote would just be this. So y, that's a horizontal line, right, equals negative 2. Okay, that's pretty easy. Now I'm just going to do domain and range. And actually, I can use these two pieces of information here to help me do that. So what is the domain? Well, the domain is going to be x such that x is not equal to 0. And then the range is going to be y such that y is not equal to -2, because that's where I have my asymptotes, and the graph can never reach that. Okay, so I like to graph those two things first. So I'm going to do my best to try to do that. X equals 0 is a vertical line. Okay. And I'm going to make it dashed. Whoops. Let's probably need a little bit smaller eraser to do that. Okay. And then I need a horizontal one at -2. Okay. Okay, so once you have these, it's a little bit easier to draw your graph. I like to just get a couple of points in there so that I'm in good shape. If I put in, let's see, if I put a 1 in for x here, I would get 1 over 1, which is 1, minus 2. So I would have 1, -1. And then I can just do that a couple times. I'd like to just get a couple of points, so I actually should maybe use a different color here. All right. So I have a point here. If you do this again, it's basically like that, and then same thing over here. And then I just want to try to get kind of close to the asymptote lines. Do your best. It's a little tricky for me with the iPad to get a good, oh wow, to get a good line. Okay, and then, all right, we'll see how this goes. Okay, well, something kind of like that. You can clearly see still a hyperbola, but we did it. And we've identified all of that stuff. I hope that makes sense. Now we're going to try a couple other ones that get a little bit harder. Okay, so this one says graph the function, or same directions, I guess. So this one does have a reflection across the x-axis, so it should be across, the branches should not be, maybe not in these two spots. Instead, it should be like this. So, all right, so my vertical asymptote is at x equals 5. My horizontal asymptote is at y equals 3. Okay. My domain then, let's write that, x such that x cannot equal 5. And then range, y such that y cannot equal 3. Okay. And everywhere else is good. Okay. So again, I would recommend getting your asymptote lines drawn in first. So x equal 5 is a vertical line. Okay. And then I have a horizontal line at 3. Okay, and then I'm just going to do some, I like, again, to make this a dashed line. This is the best way for me to do this on the iPad. Okay, so, okay, now instead, now remember there's a reflection across the x-axis, So instead of being on these two spots, like here and here, I'm going to be over in this area and this area. All right, so I like to get a point or two in there to just see where I'm at. So, I don't know, if I go 1, 5, I have a line here at 5, so I don't want that. I want to see where I'm at 4. So if I put 4 in for x, I would have -1 over 4 minus 5 would be -1. So that would give me 1 plus 3, which is 4. So really that's going to end up here. And then the other one would be here. And now, again, there's no stretch, so that's why it's always 1 unit away. So I'm just going to do, it's like a half and a half on each of these. And then, again, just do the best you can with sketching it. Okay, it should not get further away, but my... Okay. All right, I should have probably made that go down a little bit further, but you see how that works. All right, it's not too hard once you get your vertical and horizontal asymptotes in there. Let's try one that is a little bit harder. This one has a stretch. That's the only thing that's really different here, is there's a stretch of 2. And it's also been reflected across the x-axis. So I'm going to start with my vertical asymptote of x equals -4, y equals -7. We can do your domain and range right away. So domain cannot equal -4. And then the range would be y such that y cannot equal -7. Okay. All right, now I'm going to draw those asymptote lines first. X equals -4. And -7. Okay. Now, I know because, again, there's a negative, I should have stuff in this region and this region instead, because it's been reflected, instead of like my parent function. So, I know that that should be the case. Now, I like to find a point in here first. And so I like to kind of go 1 unit away or maybe 2 units away from the asymptote line to just see what I get. And so I would suggest trying that. So let's try, I don't know, like -5 or -6. Let's start with -6 and see what happens. All right, so if I put -2, -6 in the right here, -6, this would be -2, right? Which is 1 minus 7, -6. So I get -6, -6. Okay. And then it's likely to be the case over here if I put a, yeah. Okay. So now what if I put a -5 in? Then I would have -2 over -5 would give me -1. So that'd be 2 minus, that would be -5. So -5, -5. Okay, so now I can kind of use those couple points as my guide. And again, my Not super great skills on the iPad, but there we go. It's probably more my pen than anything else. So not an Apple Pen. Okay, there we go. And that is how you graph and transform reciprocal functions, excuse me. And I hope that makes sense. Here is the assignment. Turn that in when you're done. Good luck. See ya.